Hello, everyone. Hello. Happy Easter to everyone. This is episode number 20. So, yeah, it's a coincidence. I didn't plan it to have 20 in for Easter, but yeah, it's a good number, no? So that means I've done 40 streams for the same book, for 20 in Italian, 20 in English. As always, I'd like to thank Fabio Ciucci for letting me stream his book. Um, I'm quite enjoying doing this, and as always, the aim is to always to teach others how to program the Amiga, and you know, who knows, maybe tomorrow we'll have another amazing game from somebody that followed my stream. So, yeah. So this is where we finished last week. Um, so far, I've always told you, okay, that for the X, which we solved last week, we knew that we had to go from 0 to not to 5.6 but longer, okay, to be able to put a sprite on the screen fully. So far, I have told you that Y is from 0 to 255, okay, but in a way, I lied a bit, okay, just not to confuse you. I didn't want to say that you can actually go beyond the 255 and that there is a way of controlling also not just the X being over 255, but also the Y can be over 255 pixels. So, so when you're putting a sprite on the screen, you're going to see that you will not be able to move it if you do from 0 to 255 till a certain limit. You'll be able to move it. Then you will not be able to move it anymore. But we're going to show you how you will be able to do that. Okay, so the examples that follow should show that. So let's see what Fabio says. So now we have to solve the y limit, okay? So far, I always said that 255 is the limit, okay? He's also said the same like me. I lied a bit, so as not to confuse you. In the y position, the Amiga has also the 9th bit, like what we have for the horizontal position. We have the 9th bit. Um, for your to get the curiosity out of how to do it, you do this by using the special byte, which is the fourth byte of the special uh, of the data register, no, for the sprite. Now, remember what I said, that we have the special byte. We are using bit 7. Okay, remember we start from 0 to 7, so bit 7 for attach sprites. We are using bit 0, sorry, for moving the sprite horizontally from, instead of every 2 pixels but every 1 pixel. And now we have bit 1 and bit 2. Okay, bit 1 is for v-stop and bit 2 is for v-start, and I hope I got it right, because yesterday I hope I fixed my notes. So v-stop is bit 1, yes, v-start is bit 2. So in theory, okay, we should be able to cover from 0 to 511 in the y direction too. Of course, there are in 511 positions in the y direction, but there is more than I think the last one is 299, if I'm not mistaken. It doesn't matter. Once the sprite is off, we just need to reset it, no? So it doesn't matter what is the last one, to be fair. So let's see what else he says. I have told you that bit 1 is for v-stop, okay, and bit 2 is for v-start, okay. Now we need to come to this code. Now this code is quite an important part to understand, okay. It's quite important to understand. So as we had part of the code to explain the X, we are modifying the Y now. Remember, we had a routine, and the routine modified the X so that it can take the sprite that moves horizontally instead of 2 pixels every 1 pixel. This is the same routine that we had for when we're moving the sprite in the Y direction, okay, whether we're going up or down, with an enhancement, okay. So let me tell you this routine to move the sprite on the y-axis beyond 255. Notice Fabio, to help us, wrote to improve code or change in lower part. We had let me see, because I might confuse you here. Okay, so yeah, because I was going to read something that might have confused you. So we change, okay, remember we covered 3 instructions last week, which were bit test, okay, bit set, and bit clear, okay. It's the same principle. We test for a bit. If it needs to be set, we set it. If it needs to be clear, we clear it, okay. So we are using the same principle as we used for the X direction, okay. So also note, because now we have 9 bits, we are using word instead of bytes. Before this was move.byte, now it is move.word, okay. So we are reading from our table, okay, where the sprite needs to be in the Y direction, but the table is words, not any more bytes. So we read a word, we add the offset to it. Remember that the sprite from in the Y direction is visible when we reach to C, okay. So we add to C to it, okay, and then we put that in V start, okay. So our V start is set, okay. We test if the high bit is bit 8 is set. So we notice we moved in V start, okay, a byte now. So we moved the low byte of the word that we copied into the 0, okay. We test if the 9th bit is set. If it is set, okay, we set bit 2, okay. See, we are testing. If not, we set bit 2 here. If not, we unset it. We clear it here, okay. It's always bit 2, okay. The hash 2 means we are doing bit 2, okay. So here we set it, here we clear it, and of course then it jumps to do the v-stop. Now the v-stop, we need to add the height of the sprite. So the 0 that we loaded from our table, we add the height of it, okay, and then we move that byte, okay, to v-stop, but we still need to test for the high bit, okay, if we have exceeded 255. So then we do the test. Did we exceed? Yes or no? And depending on the value, we change bit 1, as you can see here, which is for bit 1. We either set it or we unset it, we clear it. And that is our routine for moving the sprite in the Y direction beyond 255. Okay, so that is you are going to see this routine used in real life in a minute, but in a nutshell, that's what it does. And in fact, we arrive to example 7L, which I will load in a minute on the Amiga. So I transfer you to the Amiga, we read our example, which I will go and explain. Okay, so we assemble it and we run it. So we have a sprite that is going around the screen. Did I do L? I did I was wondering. Read L, because it was not going to the bottom of the screen. You see, this is exactly like another example that we did. Okay, remember we had the sprite moving up and down, like bouncing like a spring, but it was not reaching the bottom. I show you, it was example 7D. Okay, so notice the difference between 7D and this one. Okay, notice where it arrives when it goes to the bottom. You see, it's not able to reach the bottom because we are doing till 255. Okay, and then we bounce back. Now with 7L, we are able to reach the bottom of the screen. So it's the same example modified and extended so that we can do the whole screen. I believe to reach down the bottom it's 299. As I said, I can't remember the values by heart, but you will find them anyway. So we have done that. Let me go through the code and explain the code now. So let's go back to the book. So you see the book and I need to see the book. So now we are doing example 7L. And the example says that it moves a sprite till the bottom of the screen beyond FF, as I'm showing on the screen right now. So this is our usual code that I explained 1,000,000 times, so I'm not going to repeat that. Okay, and now, okay, there should be, yeah, that one. This is our routine where he does a BSR, okay, branch to subroutine, where we move the sprite in the Y direction. Okay, and this is the routine that I just explained in terms of for the sprite to move beyond 255. Okay, it is exactly the same routine. Notice that the only difference from here to the book, okay, from the example of the book, okay, here 80, okay, is already pointing to our table, while here we are populating 80, so the first 2 or 3 lines. Okay, the -2 is because it's a word. Okay, so that's why. Now the table, I mean, I already explained it several times, but I will explain it again for those, because now we are changing from byte to word type of tables. Okay, but the routine is the same. Okay, it checks it moves the 0 into 80, which is the first byte of the sprite data. Okay, then it adds sorry, you see here, look, from here on is what there was in the book. Okay, it moves 80, okay, into the 0. Okay, this part, okay, I forgot to say, this part is reading a word from the table, and it checks if we have finished reading, if we have read all the table, and then we need to start again from the beginning. So that's what this part is doing. Okay, till here, till this line, till the move word 80, comma 0. Okay, so but this one I have explained it several times of how we are reading the table and then we start again from the beginning. So what is really the new part is this part, which I explained earlier, but I'm just going to show you that we are adding to C again. So the offset from where it starts in the y direction, we're storing it into v start. Okay, we test bit 8. If bit 8 is set, remember we have 9 bits now, so bit 8, remember we start from 0, so bit 8, we need to test bit 8. If it is set, okay, bit 8, then we go and set, okay, be set, okay, set the bit 2 of the special sprite, special, not sprite, special byte in our sprite data. Remember, it's number 4, so it's our sprite where it starts plus 3. That's where the values are stored. If not, we clear it. Okay, then we need to add the height of our sprite. In this case is 13. Okay, and if we exceed 255, we again check if we need to set bit 1. Okay, that is all. The table is here. Okay, and here is how he created the table using the cs command of as in pro. Okay, so where you enter these parameters, which I have explained in, I think it was in the previous one or the one before, 7e, when we did example 7e, which I believe it was the last one, yes, because it was a whole stream on one example. So these are the parameters he entered. These are where the how to say, word positions, okay, of for the y position. So there is always, although you're seeing it as byte, but each one of them is stored as word, because once we add, you know, let's see one with f. Let's see if there's one with f. There should be. Not locating one right now. Anyway, I'm seeing ef. What here, for example, we have fo. Okay, so once we do fo and we add 13 to it, okay, that's still not beyond ff, but somewhere it should have. Anyway, I don't want to be lost in it trying to find the data. It is stored, imagine that in front of 7a we have 0 0. Okay, so it's always, okay, a word, and so we can have the 9th bit on it, in it. Okay, here are the sprite pointers, which you know very well, and that's what we are setting up and where the sprite lies. Okay, and the sprite further down is we are changing, remember, these three, the sprite data, the first 4 bytes represent v start, h start, v stop, and the special byte. Okay, I'm repeating this if there's, in case somebody new on the stream. So we are basically modifying these bytes to position this sprite anywhere on the screen, and this is the sprite data, and this is the end of the sprite. So once we did this, okay, we arrive here, and here's an important note. Note that this is like example 7D, as I said, with a difference that the sprite that go beyond 255 on the y-axis. Now, this is where he says it's actually he mentions the positions. Okay, that's good. Values of 255 as y position for sprite in scanline. So basically what he's saying here is we have position, even though it doesn't look like in the table, we have positions once we are calculating, once you add 2c to it. Okay, so before we saw 2FO, no? So FO plus 2c, okay, goes further beyond the 255. So that's why I forgot that he's adding 2c. That's why we're seeing the sprite going beyond the 255 region. And actually the bottom of the screen is showing it here, so I was right, 299. Okay, so 1 2b hex, so that's when you reach the bottom of the screen. That's basically it for this example. So we can return back to the book, theory book, and we read what he's saying here. Now it's time to optimize our routines, and I will explain what he means by optimizing the routine. First, we need a routine that is a universal routine that controls our routine. So now it's time to optimize our routines. Okay, so far we had a routine for doing the X, a routine for doing the Y, and they were not combined. So now we are going to combine them together, okay, where we can give the X and Y together, and the sprite will move in the direction of the screen. Also, we will be optimizing it, because so far we haven't optimized anything. We're just we'll be merging the routines, and we will be optimizing the routines so that we can move a sprite wherever we want on the screen. So we're going to do example 7M. So I switch to the Amiga, and I go to the Amiga. So as you can see now, the sprite is going along this the screen, moving around the screen. How to say, in all till the bottom. Okay, before it wasn't. It was reaching a certain at the lower part of the screen, but it was not going doing it all. So this is a great achievement in relation to where we were before. So let's have a look at the code. So we need to jump to from the theory book to the example book. So he's saying here that we have a sprite that moves around the screen in all the positions on the screen, and we are adding to C to the Y value and 1 to 8 to the X value. So we position the sprite. I need to switch you guys to the book. So, but actually I'm realizing I need to switch you back to the Amiga just to show you something. Yeah. And I need to run the example again before I start commenting. So the sprite, okay, you should be able to see my mouse. We are adding in the Y direction, we are adding to C, so we are somewhere here, okay, but then we are adding 1 to 8, so we come somewhere in between, in the middle of the screen. Remember, 1 to 8 plus 40, which is 64, makes the middle of the screen. Remember, our screen is 320 pixels wide and 256 pixels high. Okay, so we are arriving somewhere here. Okay, and that's where we start. Okay, so when we add those values, the 2C and the 1 to 8, this puts the sprite somewhere here. Okay, and then it's either adding to this side or subtracting to this side. Okay, so if here we start at 160, position 160, if we have If we are moving to the left, we do minus, I don't know, 1 pixel, and moving to the right, we do an addition of plus 1 pixel. Okay? So now we go to the book. Before I jumped to the book to Ellie. Okay. So as I said, okay, we add 128 into the X position, okay, plus the 64 that we have in the initial beginning, and 2C in the Y direction. Okay, so that is always to be able to move the sprite anywhere on the screen. So we have the routine to move our sprite. Okay, so we go here. Okay, now this is our universal routine. Okay, now the universal routine needs 4 parameters. Okay, A1. Okay, you're going to see them actually down here. Look. Okay, you're seeing them now here. A1, which is the sprite address. Okay, D0, which is the position of the sprite in Y position. D1, which is the position of the sprite in the X position, and D2, which is the sprite height position. Okay, not position, the sprite height. So the first thing it does before we even enter our routine, you know, our universal routine, this uni is universal routine. Okay, it's our universal sprite move routine. Okay, we have, remember, we are reading the position of the sprites from the X table and from the Y table. So we need to jump to this routine ledger table, which means let's read our table. And our table, I mean, does 2 things. Reads the X position, sorry, the Y position. The first one, this one, is the Y position, and this one is the X position. Okay, they are a copy of each other, but one is reading the X, one is reading the Y. Okay, so this one, the first one is reading the Y, and then we have reading the X. Okay, it's the same type of thing that I discussed earlier. Here we are checking that we have not reached the end of the table, and if we have reached, we start again from the beginning. And notice, once we read the value, we put it in the 0. This is the Y value where it needs to be. It needs to be in the 0. Okay, the same thing, okay, we are doing for the X, and once we read the value, we put it in the 1. That's where the value of our X position needs to be. And notice that they are word. Okay, actually the X is word. In this case we are moving byte, so our table for the Y values is a byte, not a word. Then it needs 2 more parameters, and for those that do not remember, I'm going to repeat them. It needs the pointer to where the sprite starts, the LEA Mio sprite, where our sprite starts, and then the height of the sprite, which is 13. Okay, so once we have our parameters, okay, we return back to the routine that I was talking about earlier. However, before we do that, below this routine there is how he generated the tables. Okay, this is our pointer where we are in reading the table. Okay, so when we arrive at the end of the table, we know we need to set this up to 0 basically, or -1. This is how, you know, this part in blue, okay, is how he created the table, and here we have the table that we are loading for the Y coordinates, and he's saying that there are 200 values for the Y coordinate in in bytes. Okay, for the table X, we are saying, he's saying that there is 150. Okay, and from those 150, we have 150 of word, not byte. Okay, so we've done that, and we return back to where we were here. Okay, so we've done this. Now we have the 4 parameters filled up. After we call this routine, we have these 4 parameters filled up, and we arrive to our universal routine. So we call the universal routine here. Okay, and so let's go and find the universal routine, which is further down. There you go. These are the comments for the universal routine, and these are the parameters which we filled. So he's repeating them in more than one place. Okay, now what he's doing here, he's doing exactly what I had explained earlier. Okay, so he's moving, he's adding 2c to the 0. So basically now the y value, remember the 0 holds the y value. When we add 2c, it can be beyond 255. So we changed it into a word. Okay, so the value that we have in the 0 can be 9 bits now, and we store that into our we store byte, the first 7 bits of our 8-bit word. Okay, remember we start from 0, into A1, which is the first byte of where the sprite is. We test if we need this part. Okay, we are testing if we need to set bit 2, okay, for vstop in the special byte. If we are beyond the 255, then we need to set it or clear it. So it's a check that we are doing. Then we do the same for vstop. We add the height of the sprite. The 2, remember, holds the height of the sprite. Okay, we store that in the 0, and we move the 0 into the third byte of the sprite, which is vstop. Okay, once we've done that, okay, we see if we need to check and set the bit for vstop, which is the first bit. Okay, as you can see, we're setting bit 1 of in the special byte for vstop. Okay, now we are going to do the x. Okay, the x, we are adding 1 to 8, okay, to it. Okay, the value whatever we have in whatever value we read from the table, we are adding 1 to 8 to it, and then we test if that value needs to test bit 0, okay, of our special byte in the sprite data, whether this needs to be set or not. Remember, it is either odd or even. Odd or even. If the number is odd, we set it. If the number is even, we don't, because odd numbers always end up with a 1. Even numbers always end up with a 0. I mean, in binary, I mean, okay. And if we need to set it, then we shift it. This is the same routine that we've done in the previous example. We shift it by 1 because we need, if it's 9 bits, and we need the first bit is bit 0 is the bit that tells us whether we are doing where we need to set it or not. We shift it, and then we set it up. We move the rest of the bit of what remains into the second byte, which is h start. Okay, that's, I think, basically it for the universal routine. Okay, so here he's reminding us that we could have done, okay, if A1 holds the sprite data where it is, so V starts at the position of A1 where it is A1. The second H starts is 1 plus A1, the pointer of our sprite. V stop is 2, to the position of A1, and the special byte is 3 to the A1. Remember, A1 holds the pointer where our sprite data is. And I think we arrived to the end of that. So we go back to the book. We did 7M. No, that was 7M. What we were doing before I switch you to the book. That was 7M. No, that's what we were doing. Yeah, 7M. Okay, so let's continue with the book. Okay, so we've seen our universal routine. So the universal routine, as I said, is very important. You need to really understand it, but then in a way you need to forget it, because all you need to be caring about is passing those 4 parameters in H0, D0, D1, and D2. Okay, so here is an explanation. Let me see if there's some note here that I didn't explain yet. Here is repeating what I just said. The universal routine needs the height of the, yeah, he's mentioning that it's an important thing not to forget that the universal routine needs to add the height of the sprite to vstop. Okay, and here he's saying that what I just said, A1 needs to hold the address of the sprite, D2 the height of the sprite, D0 the Y value, D1 the X value. The X and Y are the screen values, okay, of 320 by 256. Okay, so we have a screen of 320 by 256, and those are the values that we need to enter there. The routine centers the sprite horizontally on the screen by adding 1 to 8 to our data, and also makes it appearing on the screen in the Y position by adding 2C. So he's mentioning the 2C here, that is added to the Y, and we are doing 40 plus, where is the 1 to 8? Someone is mentioning the 1 to 8 to be in the center of the screen, which I'm not seeing here, but he mentions it for sure because I wrote it. Anyway, I highlighting the code again. This is what we did. It's what there is in the example that we just did. Those are the parameters. And here there's a note that says example 7M is very important. Okay, he is saying this and I cannot agree more. It is very important. Make sure you understand how the routine works, and not understood and understands. Okay, so I cannot be more specific than that. Okay, since this is fundamental from now on. Okay, all sprite movement is handled using this sprite routine, and from now on, okay, every time we use a sprite, you're going to see this routine, which in the beginning I started explaining it, I mean talking about it, but then it's repeated so much in the book that I stopped mentioning it. I was skipping it and telling you, look, there's the sprite routine, our universal routine, and those are the parameters that you need, because as we will never finish the book if I need to explain each routine that we do, that the book covers. Once I explained it, you need to know what it does. So we arrived at example 7M, N, sorry. So we should jump to the Amiga, I believe. Okay, and now we have a sprite that is bouncing around the screen. Now, the difference between this example and the examples that we had before, okay, is that this one is not reading from a table. This is being calculated as the sprite is being moved. Okay, so before the sprite going around the screen, it was reading from a table the x and y coordinates. Okay, now we are not doing this, which I will explain the code in a minute. But one thing you need to know, which I already stressed about it, this is using the universal uh, sprite movement routine. As you can see, Fabio wants to demonstrate that that routine can read values from a table and display the sprite on the screen. My God, they rhyme. uh, or it can read values from a table, and once you read the value on it, you display this sprite on the screen according to what you read from the table. And the table, remember, it's two tables every time. One table contains the x coordinates, one table contains the y coordinates. So like that you can also vary. If you had to do them in one table, if you had to do it in one table, then it will be difficult to vary the x or y, which we saw it several times how he's varying the x and y in the table. By the way, the tables he creates are also, they are very good. Actually, I did explain this, but the tables are very good for the same principle is basically used whether you use a Commodore 64 or any other machine, even a PC in today's world. Okay, it's the way you apply data to move something. So the principle still is the same after, I don't know when this was invented, before the Amiga for sure, but yeah, reading values from a table and then moving that across the screen. So let's go to the book, and as you know, the theory book, that was the theory book, and we need to go to the example book. Okay, so he's saying that this routine reads not from a table, but it's calculated, okay, while the sprite is moving. And this is the routine. Okay, so first of all, the code is duplicated. Okay, here we are moving the sprite in the y, and here we are moving the sprite in the x, but it's the same code, duplicated code, just we are working with different registers and in different data, because we are using the x instead of the y. So I'm going to explain the y, but what I say for the y applies for the x with different numbers. Okay, so this routine calculates and updates the y value. Remember, this is stored in the 0, okay, the y value, okay, to the universal routine. This is what we are passing to the universal routine. Okay, what does this code does? Okay, so we get the value of the sprite y position current one, where it is. Okay, so that's what it is doing up here. Okay, then we add a value of where we want it to be, so we add an offset. Okay, then we test whether we have reached for the border, we are hitting the border. Okay, so in the case of the y, whether we are hitting the border down here, okay, or whether we're hitting the border up here, and since we are doing the y, okay, that's why it has these values down here. Okay, so if we hit the bottom, okay, it changes direction. Now there is a new instruction that we haven't covered, which I will explain. Okay, it is the negate instruction. Negative, so whatever is positive becomes negative, and whatever is negative becomes positive. I do not need to write on the screen. You should be able to understand if it's -1, it becomes +1. If it's -7, it becomes +7, and vice versa. If it's +7, it becomes -7. If it's +1, it becomes -1. That's what this instruction does. Okay. The rest is the same. We are using the testing routine. There should be bit test btst somewhere. We are using it here. This is you know, we are adding the velocity. So when we are moving the sprite, okay, I need to be careful what words I use. That's why sometimes I pause. Okay. What the sprite is moving across the screen, but it's not moving by one position. It's moving by more than one. So, and he's calling that the speed, and he is adding that value. So once that value reaches a certain value, which is the end of the either the top or bottom of the screen, okay, that's when we know that we need to do the negate. Okay, and he does a check on that. Okay, so also remember now our sprite moves in in the Y using 9 bits from 0 to 8. Okay, so from bit 0 to bit 8, that is 9 bits. So he is using word. Okay, so basically here this is the calculation. We are populating the 0, and before once we calculate it, we store it into the sprite Y position. Okay, same we are doing for the X. Okay, we calculate the X position, okay, which we have in the 1, but we store it. Okay, we need it to calculate. So basically we read what we had. Okay, let's say the position of the sprite in the Y position was 100. Okay, and we are moving the sprite, I'm just going to say a velocity of 1. So we are adding 1, okay, to the sprite, just to keep it simple. Actually, he's doing 15, both in the X and both in the Y, as you can see. Where is the head? I thought he was doing 15. Sprite speed X. Okay, sorry. So he's doing -4. They are down here. I thought he was doing 15, so I do apologize there. So the speed in Y is -4. So when the sprite starts from the top, so it's -4, it goes to the bottom. Okay, and the X is 3. Okay, so he's doing +3, and because we are moving the sprite towards the bottom, we're doing upwards, we're doing a -4. Okay, and this is the position of the sprite, the X and Y, where they start, where it starts basically. So sorry, I said 15, but it's down here for some reason. I saw this 15 and I think that 15 confused me, but that is testing for bit 15. So once we calculate the sprite and we store our values, okay, so if we were at 100 and our speed, let's say it was +3 in this case, we reach 103. Okay, so we store that 103 in here in the sprite position. Okay, whether this is X or Y. In our case, I was talking about the Y, so we store it in this word. Okay, and then the next time we read it again, okay, and we add another 3 to it. So that is what he's doing. But what you need to understand is after the calculation, okay, where he adds 3 or -4 or whatever, he is storing it, okay, and also we have the value in the 1. And remember, the 1 is the X position for the sprite, and the 0 up here, which he's storing it also, is the Y position for the sprite, okay. Then he adds, he makes sure that the A1 has got the sprite pointer where it is. He makes sure also that D2 has the height of the sprite, and then he calls our universal routine, okay. So that's basically it. I mean, nothing much. Instead of reading from a table, we are calculating the sprite before we actually move the sprite on the screen by as I said, by using these speed values, okay, -4 and 3. So this -4 then becomes +4, okay, and when it encounters the negate instruction, and this 3 becomes -3, okay. So that is what's happening here. If you notice, look, speed Y, the negate instruction is working on speed Y, and is working on down here on speed X, which are these two, okay. Then where were we? Movie sprite. So he called it okay, so he called it. So we came to this routine. Then okay, and from this routine he's calling the universal sprite, okay, because I was wondering where he's calling it. And this is the routine that I just already explained with the values already populated from this routine, okay, to move across the screen. So this is the universal sprite routine that I explained, okay. As you can see, we are not having any data. There is no include bin or define constant word or define constant byte that shows data of tables for the X or for the Y. The only defined constant word we have is for the sprite data, the sprite definition, okay. This is our sprite, and these are the 4 bytes that tell the Amiga where the sprite is in the X and Y position, okay. Nothing else. As far as I know, there isn't anything else that I need to explain. Let me make sure. Yeah, so we did 7N. Let me go back. So yeah, we did 7N. Let's do 7.0. Let's see if there's any notes to it. Okay, so 7.0 is basically the same thing, but this time a bit enhanced. We are going to have 2 sprites on the screen instead of 1. So we move back to the book, and I prepare the book, and then we move to the Amiga. We read 7.0. As you can see, they are being read from a table. This is not pre-calculated, not is calculate. The sprites are not calculating where their position is, okay, but they are reading their position from 2 tables, actually 1 table for the X, 1 table for the Y, okay, and both sprites are using the same tables, okay, which I said, table for the X position and table for the Y position. However, they are, if you notice, they are following, one is following the other. The reason why is they started in a different position in the table. Let's say one started at position 0 in the table, while the other one started in position 100, okay. So that's why they are at a distance from each other. because they started differently. I will explain the code. So the example, as I said, it uses the universal sprite, and we move two sprites on the screen, and they are reading from the same tables. Okay, same table, one for the x, one for the y. Okay. Here is our routine that shows we are going to the sprite, to the routine that moves the sprites, and the routine is very easy actually. I mean, it's a repetition of what we had before, but instead of having one routine, it's twice. Okay, so this is the same routine as we had before from reading a table, but for one sprite. Okay, so it read the x, sorry, it starts with the y. It read the y position of the sprite. It read the x position of the sprite. Here you can see it's reading the x, okay, in this part, okay, and populated the registers, okay, 80, D1, D2, D0, D1, D2, okay, as you can see here, okay, it populated those, and it called the universal sprite routine. I made it in color like that. As you can see, it's being called twice. Okay, so it calculates one sprite, treats the values from a table for one sprite, fills up our registers, and then calls the universal routine, and does the same thing for the other one. Okay, so it's the same code, not as this is example 7.0, if I'm not mistaken. Is it 7.0? This is 7.0. 7n was the calculation without using the tables, so it is 7. My God, alphabet. 7m. Okay. I could not do the alphabet in reverse. So it's the same routine that we did in 7m, but twice, and that is twice here. So I explained this routine in 7m, okay, or this routine, because it's like that, you can see it. I explained this in 7m, okay, and then calling the universal sprite, but we have two of this routine, nothing changed. It's the same code, okay. And here you can see, okay, the offsets for the first sprite, okay, which are at the beginning of the table, and the second sprite, table y.2, okay, one starts at 40 in the y position, okay, and the other one starts at 96. The -2 and -1 is because either we are reading word or a byte from the table. So as you can see, the y is a byte, so 200 values of byte, and the x is 150 of word. Okay, that's basically it. And here is our universal routine. Eventually I will stop showing this, okay. Right now I'm highlighting it with this color. Eventually it will be skipped, like when you have the code here, because it's repeated so many times. It's ridiculous to go and explain it each time, or even comment on it. But yeah, this is the sprite universal routine that moves our sprite on the screen. So okay, I believe I done this example. Let's see, there's a note at the end of it. Yeah, so basically the routines up here, of course. Not the universal sprite, but these ones. Notice that for each one of them, okay, we are passing a different sprite pointer. Okay, here we have sprite 2, Okay, and here we have Sprite. What is it? Sprite 1 basically doesn't have 1, but it's Sprite 1. Okay, and that is in A1 because A1 is the address of the sprite. Okay, um, but there are two different sprites, and which are defined here. This is one of them, and this is the second one. Okay, um, that's basically what he's saying that there. So just wanted to show that, hey, it's the only difference is that we are passing a different sprite pointer, but the calculation is the same, and there is an offset which I explained. Okay, so let's do 7p. 7p, I believe, yeah, is one of the last ones. So let's do example 7p on the Amiga. Let's read it. Okay, so here, okay, we have 4 sprites. Okay, remember each sprite of the Amiga is 16 bits wide. Okay, 16 pixels wide, not bits. Okay, so we are using 4 sprites to have, actually 5 sprites, sorry, not 4. Okay, to have the word Amiga written and bouncing around the screen. Okay, it's reading the values from a table, as you can see, and it's following a pattern. Now, there's something interesting that you need to know. These sprites, all 5 of them, okay, has got the Y position always the same. Okay, wherever they are on the screen, the Y position is always the same. Okay, the X position, okay, for the first one is read from a table. Okay, so remember we have a table for the X and for the Y. So we already established that the Y position for each 4 of them, okay, is the same. So you read it once, you don't need to read it 5 times. Okay, you read it once and then you pass it to the universal routine for each sprite, but you just read it once. For the X, okay, you also read it Y. The others are offsets of 16. So the first sprite is at 0, then the second one is at 16, the third one is at 32, 48, and they continue so forth. Okay, so that is why uh, you are going to see the code, but the code only reads the table once. Okay, and then just adds offsets to each sprite in terms of X, because Y, as I said, is the same. It's the same theory or practice that you can do also on the Commodore 64 if you want to display something with sprites on the screen and like bouncing like this. It's the Y is always common, the X is offset of 24 pixels because the sprites on the Commodore 64 are 24 pixels wide. So I lost track of myself what I was doing. No, okay, so there you go. Thank you. So I was talking and sorry for that. I was talking without doing showing you what's actually on the screen. So as you can see, the sprites are going around the screen. The sprite is on the screen, and as I said, the Y position, okay, is always the same for all 5 of them, while the X position is read once from the table like the Y, but then the other sprites get an offset of 16 from that X position. Because of that, the also the sprite, okay, where it reaches here, somewhere here, and the X position cannot be longer than this vertical position, because when you add the other sprites, it will be out of the screen as. So it the X position arrives till somewhere here, and that's it. Okay. Anyway, so I highlighted this in yellow. I mean, this is something that we have had before several times, but I highlighted it to remind you guys that before we had just one sprite, so we were setting the sprite pointer only once, but because we have 5 now, we are setting it 5 times. Okay, that's the only reason why we are sorry, 4 times. I continued saying that it is made of 5 sprites, but actually it's made of 4 sprites. The logo that you were saying that you have seen in the previous example, not in the previous, in this example on the Amiga. So this is setting the 4 sprite pointers. Okay, just before we were only seeing till here. Okay, we were only seeing this part. You are only seeing that because we only had 1 sprite. Okay, but now we have 4, so it's a repetition of the same code but 4 times. Okay, here is we move all our sprites. So what does move all our sprites mean? As you can see, I have the habit of highlighting things with different colors, but the first part is getting the X and Y. I always start with the X as a habit of how we say things, but actually we start with the Y. As you can see, it's reading table Y, okay, first, and then we read table X. Okay, so we populate the value for the X and the Y where the sprites needs to be on the screen, where the sprite needs to be where the first sprite needs to be on the screen. Actually, this is for the first sprite. Okay, so we read from the table and we calculate where that sprite needs to be. Okay, then we put in A1 the sprite pointer. Okay, then we add the height of the sprite, which is so where is it? The 0 and the 1 are our X and Y, and the height of the sprite, where is it? We don't need, actually, it's here where he has to edit. We don't need, it's already specified as 13, I believe, somewhere in the sprite definition. That's why we are not seeing it the first time. So as you can see, we are reading 4 sprites here. Where is the sprite data? Yeah, the sprite data is because we are reading them from files. It's here. Okay, it's here, and it's saying by default, I believe it's 0. So that's why he doesn't need to bother about it. Yeah, I believe it's 0. Yeah, these are the sprite pointers, but he's not setting anywhere H start, V start, and V stop. Okay, so he's assuming everything is 0. That's why. And these are our tables. Okay, one is for the Y and one is for the X. This is the X table, this is the X, and the Y. So the X table, we can see it as defined constant byte. Okay, here. Okay, and it is part of the source, while the Y, okay, is not. Okay, he's including it. He's importing it from a file. This is to show the different types of files that we can have. More than anything else, it's not, there's no difference. So this is where it is that I highlighted the wrong thing. So D2, okay, this is not part of the routine that gets, so the routine is still here, okay? It's from here to here, okay? From here to here, we're getting the X and Y, okay? D2 is the height of the sprite, okay? Where we see Amiga, okay? And then we are moving the sprite pointer for the first one, and we are moving into the 0 and the 1, the X and Y, because this routine, okay, stores the X, the Y and the X not in the 0, that's the only thing difference from the previous routines, but in the 4, because we are going to do calculate, we need to remember it. So to remember them, he's using other registers that are not used by the universal routine, okay? So, and then in each routine, because the Y is the same, okay, he's moving the 4 and the 3 always the same value, okay? Actually the 3 is not, because it's the X, okay? He's adding 16 to that, but it's calculated basically. But the Y, if you noticed, the 4 is the Y value, okay, which he's calculating up here. In all 4 sprites, the 4 is moved to the 0, okay? And in the 3, okay, he's adding 16 to the 3. The 3 holds the X position, okay? And he is adding 16 to each sprite, one next to each other, to be able to be displayed. At the end, when he passes the parameters, he's always calling the universal routine, the uni move sprite, okay? Universal. He's doing it 4 times, okay? 4 times it's there. That's basically it. I want to see what other notes I have in relation to this. Yeah, I already said that the table, one of them is include bin, and the other one is actually as data. Okay, so that's what I wrote in my notes. One of them is byte, and both of them are actually byte data. Okay, so the format is always in a byte. Sometimes he uses Word, so you need to be careful about the type of table he generated, okay, or you're going to generate, because you learn how to generate that. And this is, look, I'm not giving it any more importance. I'm using yellow. Normally when the code is important, I use magenta or red or some other color, but yellow, I use it for less important code. So because it's repeated so many times, the universal routine, I just highlighted it to say that this is the universal routine, and that's basically it. I don't think there is anything else in relation to that example. I'm just going to show you the example again. The logo Amiga bouncing on the screen with the same Y values for all sprites. It's coming, and then adding the width, which is 16 pixels to each one of them every time, which was stored in the 3, and the 3 was added 16 each time, and then passed. The value of that calculation was passed into the 1, if I'm not mistaken, where it was passed to the universal routine. So back to the book. So what what I was saying is the 3 holds the X position. We were adding 16 to it, and then we were moving it into the 1 because that's where the X position is for the sprite X position. Okay, and then we move it to the universal routine, which positions the sprites on the screen. So notice that there's a difference between attach sprites and sprite adjacent to each other. Okay, one next to each other. Attached sprites, one on top of the other, gives us 16 colors, and also we have 4 sprites, not 8. Okay, adjacent sprites, okay, we have the same sprites. We can form a sprite of 1 to 8 pixels. Now 16 times 8 is 1 to 8 pixels wide, so we can have an enemy boss of 1 to 8 pixels wide on our screen, and 256 tall and more if we want to on our screen. So you achieve that by positioning the sprite one next to each other. Okay, so they are called adjacent sprite. So don't mix adjacent sprite with attached sprite. Attached sprite is one on top of the other. Okay, and because of that you have 16 colors. It's like you're having 4 bit planes, while a normal sprite has 2 bit planes. In a way, I mean the way you define the data. That's what I mean by bit plane. Bit plane is not really the right word, but you know, it's a plane for the sprite plane. So also he is explaining that you can create a certain effect with sprites. So let's say you have a sprite at a distance and you have 1. Once it arrives close to you, you know, the sprite is getting bigger and bigger, you can have 2 sprites. Okay, and that makes it look like the sprite got closer to you. Okay, it's one of the tricks when using sprites. But of course you're using 2 sprites, so it's the same sprite. Look, it's the same sprite that we have here, but this part, but this one, okay, is 2 sprites. Okay, so here in the middle of it is 1 sprite, and here is the other half of the sprite. Let's see what he says here. Yeah, basically you by positioning sprites one next to each other, he can say that we can have 8 sprites of 1 to 8 pixels, while if we do attach sprites we have 64 pixels, because you can also position 4 sprites which are attached sprites one next to each other also, but that gives you a boss of 64 pixels, not 1 to 8. Okay, so in the next week we will be covering how to control with the joystick. Okay, so thank you very much for following me. Bye, and see you next week. Bye.